Algebra 2 and Math Model Spring Break Packet 2011. Here on the left is Mr. Beck Smith, my pool-playing buddy and department chairman, again the author of this packet. 20 problems of varying difficulty and complexity to help you stay fresh and focused at this crucial time of year. Problem 1. In this problem we have two quantities or variables in this situation. We have the outside temperature and we have the hours of air conditioning use. The main question we need to ask to determine which quantity is independent is which comes first. What do we have to know first before determining what happens next? The cause and the effect. Figure out what happens first. Place it on the independent quantity line, then write the other variable on the dependent quantity line. Problem 2. Determine the independent and dependent quantity for the situation. We have the weight of the object and how far you can throw that object. Write the thing that happens first on the independent quantity line, then place the other quantity on the dependent quantity line. Problem 3. To join a health club, Jennifer must pay a $99 startup fee and a $45 fee for each month. What equation describes the total cost y of the club membership for X months? Really, to do this one, it's necessary to understand the slope-intercept form of a linear equation y equals mx plus b. The m, or the number next to the independent variable, is the slope, and the b, the number by itself, is the starting point, or the y-intercept. In the text, there are keys of how to write the equation. Words like for each, for every, and a piece indicate the slope, or rate of change. And for the y-intercept, words like fee, flat fee, down payment, starting amount indicate y-intercept. So I leave it to the viewer to figure it out and write an equation or function to describe the situation. The equation should look like y equals some number times x plus another number. Problem 4. What rule determines the relationship in the table below? We take a good look at the table and notice that on the left side, as we go from 1 to 2 to 2 to 3 to 3 to 4, that it's a difference of 1 between each integer. And on the right side we have the differences between 13 and 21, and then 21 and 29, and then 29 and 37, for 8 apart each time. So the slope will be 8 over 1, or 8. So after finding the slope, what's left to find is the y-intercept, and then write the equation in slope-intercept form y equals mx plus b. Problem 5. What function would produce the table of values given below? The first thing I recommend doing is to create a vertical table of values in order to evaluate something we're a little more familiar with looking at. In order to evaluate the relation, draw arrows on each side of the table. These numbers, both at the left side, go up 2 at a time between each number, and on the right side as well. We find the slope by taking the right hand over left, or 2 over 2, which equals 1. Now with the slope, find the y-intercept, and then with the calculated slope, write the equation in the slope-intercept form of y equals mx plus b. We'll need to find the y-intercept. Good luck. Problem 6. What is the domain and range of the linear parent function? First of all, what is the linear parent function? Well, it's y equals x. And if you graph the linear parent function y equals x, this is what it looks like. Arrows at the end of both ends of the line are the key to getting this problem correct. Problem 7. What expression is equal to 4x squared plus 5 plus quantity 3x minus 2 plus quantity x squared minus 8x? Note the use of the word quantity. That word means that the next two terms mentioned are inside parentheses. What we need to do here is combine like terms. The like terms here are x squareds, and we have 2 of them. And we have x's. Again, 2x terms, 2 of them. And finally numbers, 2 of them. So the answer will be plus or minus something x squared, plus or minus some number of x's, and plus or minus a number. Problem 8. What is the simplified expression for the area of the shaded region? It's simply the area of this rectangle minus the area of the triangle. The area of the rectangle is found by taking the length of 4x times the width of 2x plus 1. And the area of the triangle is found by taking 1/2 of the base of 2x minus 2 times the height of x. Problem 9. For the equation 6 minus 3y equals negative 4x, find the following, and we're asked to find the slope, the x-intercept, and the y-intercept. I think that the easiest way to solve this problem is to change the equation to slope-intercept form. First, move the x on the left to the right side of the equation, where it shows up as minus 6, and after that divide the whole equation by the coefficient of y, which is negative 3. Don't forget that there will be negative 6 divided by negative 3 on the right side for a y-intercept of, I believe, negative 2. Problem 10. What is the equation of the line that goes through the points 2, negative 1 and 8, negative 7? One way to do this is to take the slope formula m equals y2 minus y1 over x2 minus x1. But a way I like better without a calculator is to place these 2 points into a table. We draw arrows on either side of the table. And on the left we have 8 minus 2 equals 6. And on the right we have negative 7 minus 1 equals negative 6. And that gives us a slope of negative 6 over 6, which equals negative 1. So the equation will be y equals negative x plus the y-intercept, which we hope you'll be able to find. Problem 11. If y varies directly with x and y equals 18 when x equals 40, then find y when x equals 36. This problem is simply a proportion. We have 18 over 40 equals y over 36. So now all we'll have to do is solve for y by cross multiplying 36 and going from there. Problem 12. How will the graph of the line y equals 3x minus 7 change if the y-intercept is changed to negative 5? To me, the best way to start this problem is to actually graph the line. We first look at the starting point, the y-intercept here at negative 7. We mark the y-intercept at negative 7 on the y-axis. Since our slope is 3, we mark from the y-intercept a rise of 3 and a run of 1 to the right. We mark our second point of the line. Now we draw our line through the points. Now to answer the question, change the minus 7 in the equation to minus 5 and graph the line and then explain what happens. Problem 13. The sum of Scott's and Kylie's ages is 64. Scott is 32 years older than Kylie. What system of equations can be used to find Scott's and Kylie's ages? We have two sentences. First, these first two sentences, that when we translate English to algebra, we solve the problem. The next step is to identify the variables. We'll let Scott's age be S and Kylie's age be K. In this first sentence, the word and is a plus sign. And the word is an equal sign. And of course, 64 is 64. So we have now translated that first sentence, S plus K equals 64. I'll leave it to the viewer to complete the translation of the second sentence. Problem 14. Ethan already owes the library $3.75. He currently has 3 overdue CDs on loan from the library. The fine for overdue CDs is 25 cents per day of the CD. If Ethan owes the library a total of $5.75, how many days were his CDs late? With the $3.75 and the $5.75, I couldn't make sense of both of them, so I think we have to make an assumption. So I'll assume that this $5.75 last mentioned is really the same amount, $3.75 mentioned earlier, so I changed that second one to $3.75. Since each CD costs 25 cents for every day it's overdue, and there are 3 overdue CDs, it seems that the overdue charges per day would be 3 times 25 cents or 75 cents per day. How many days at 75 cents per day would it take to get from 0 to $3.75. Problem 15. Jacob has a jar of 537 pennies and nickels. The total value of the coins is $20.84. What system of equations can be used for finding the number of pennies and nickels Jacob has? This problem is similar to problem 13. We need to define the variable, so we'll let P be the number of pennies and N be the number of nickels. We need to know the value in dollars of a penny and also of a nickel to solve, since $20.94 is in dollars. A penny's worth is $0.01 and a nickel's worth is $0.05. So for the money or second equation, we have 0.01 times pennies, or P, plus 0.05N equals the total amount of money, or $20.94. Now from here we'll leave it to the viewer to determine the first equation from the first sentence, and that sentence would be Jacob has a jar of 537 pennies and nickels. Problem 16. Tamara has $250 to spend on her dress, shoes, and accessories for the prom. If Tamara spent $142.50 for her dress, and S represents the amount she can spend on shoes and accessories, what inequality describes this situation? This problem should be pretty easy. What is the amount Tamara has to spend? It's $250. If she can spend up to this amount of $250, how do we write that? We can write it as less than or equal to $250, and that fixes the right side of the inequality. Now we'll leave it up to the viewer to incorporate all the other information, the $142.50 for the dress, and S into the left side of the inequality, and thus complete writing the inequality. Problem 17. What will happen to the graph of y equals 5x squared plus 3 if the coefficient of x squared is decreased by 3 and the constant is increased by 1? To do this problem, we need to know two things. We need to know that this number to the left of x squared is the coefficient of x squared. And we need to know that this number is the constant, or constant term. Problem 18. What are the zeros of the quadratic equation x squared plus 4x minus 12 equals 0? In this problem, we're looking for the value of x where all of this on the left side of the equation, x squared plus 4x minus 12, equals 0. This word zeros could be replaced by roots or solutions as well. This can be solved by graphing, factoring, completing the square, or the quadratic formula. Another way to do it is to substitute numbers for x until it works. For instance, if we were to let x equal 1, we would have 1 squared, or 1 plus 4 minus 12 equals 0. And since that's not true, we go on to another number, or we try another method. You can try 2 and 3, see if it works. Let's try a method we can do without a calculator. From your formula chart, the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And for this equation, a is 1, b is 4, and c is negative 12. Now all we have to do is substitute these numbers for a, b, and c in the quadratic formula, and we can solve it, which I'll leave to the viewer. I will point out that the discriminant here under the square root bracket, which will be 16 plus 48, is positive, meaning that there will be two solutions to this equation. Problem 19. What value of n will make the statement true? For this to be x to the ninth, these x's with their exponents on the left side must simplify to x to the ninth as well. So in order to simplify, x to the n over x to the fourth must equal x to the third. The answer is going to be that exponent of x in the numerator, n. It has to be the correct number. Problem 20. The volume of the rectangular prism is 168x squared y squared. The length is 7xy and the width is 3y. What is the height of the rectangular prism? This monomial, 168x squared y squared, is the product of the length times the width times the height of the rectangular prism. And here we are given the length and the width, 7xy and 3y, two of the factors of the volume of the prism. We can multiply these two factors together, and 3y times 7xy equals 21xy squared. All we have to do now is figure out what times 21xy squared equals the volume, 168x squared y squared. And when the viewer figures that out, he or she will have the answer to the question, the height of the rectangular prism. This has been Algebra 2 and Math Model Spring Break Packet 2011.